Here is a scale drawing of most of Australia. The scale, as represented here on the picture, it says 1 to 40 million. So that means any measurement that you measure on your map is, in real life, 40 million times bigger. If we zoom in, say, towards Sydney, the scale has now changed because the map has become bigger. So the scale here is 1 to 400,000, meaning any measurement that you make on your map is 400,000 times bigger in real life. Zoom in a little bit further, closer to Sydney, you can see the scale's changed to 1 to 200,000, meaning everything in real life is 200,000 times bigger. So you can see any measurement that you make, you need to multiply by 200,000 to find out what its real length is. So scale drawings are the same shape, just a different size, and they should have the scale ratio drawn on them somewhere. So the way we set the ratio up is we put the drawing length, so the measurement on the drawing, in relationship to the actual length in real life. So the drawing length is what you draw on your picture, and your actual length is what it is in real life. When you have a scale of, say, 1 to 100, it means that in real life you've got something that's 100 times bigger. If the scale is around the other way, where you've got the larger measurement of your scale first, it actually means that the model is 20 times bigger. So that you might use that kind of thing when you're talking about like microscopic images, and when you want to draw them so people can see what they look like, you actually draw them bigger than what they are in real life. It's always helpful to have the scale factor with a 1 in front. The scale written with a 1 in front, because the second number is your scale factor, and that tells you how much bigger or smaller the drawing is. So scale ratios, that if they don't have a 1 in the beginning of your ratio, you can always use multiplication and divisions to make it that way. So to convert a scale distance to an actual distance, or vice versa, you can just use this idea. So going from the scale distance, you multiply by the scale factor to get the actual length, or if you're going from the actual length and you want to know the scale distance, you just divide by the scale factor. You have to know your units of measurement really, really well. So if you're not sure, you might want to write a summary of this, for how you change from kilometres to metres, then metres to centimetres, or vice versa. You really need to know that off by heart. So looking at this model, if it was 90 centimetres long, and the scale was given as 1 to 500, so remember this, because it's got the 1 in front, it means in real life it's 500 times bigger. So how long is the actual boat? Well, to work it out, we just take our 90 centimetres and we times it by our 500. So we don't normally talk about things that are 45,000 centimetres. So if we divide it by 100, we can turn it into metres. So in real life, the boat would actually be 450 metres. So it's always good to have the measurement in a sensible unit. So if we had that model boat that had the scale of 1 to 500, find the scale length for an actual length of measurement on the boat. So say the mast was 50 metres. What is it actually in the drawing? So now we're finding out from the real length back to the drawing. So we take our measurement and we divide it by our scale factor, which is 500. Now it's a bit hard to divide 50 metres by 500. That's what we're dividing by 500. So I turn that 50 metres into centimetres first, and then do the division. So the scale length on the picture needs to be 10 centimetres long. What's the scale factor when you've got 4 millimetres on the scale drawing, representing an actual distance of 50 centimetres? So you set up your ratio, and remember then to make them into the same units. So 50 centimetres, times it by 10 to get millimetres, and then we can simplify that. Once you've got the same measurement, you don't need to write the measurement in, and then we can simplify that by dividing both sides by 4, and you get that. So the scale factor is the 125. Once you've got that 1 in front, you've got the scale factor as your second number. In the second example here, we've got an actual length of 0.1 millimeters, so something that's really small has been drawn a bit bigger. It's been drawn by 3 centimeters. So you set it up the same way, where you've got your drawing length to your actual length, and then we start thinking about simplifying. So first of all, putting them in the same units. So it was easier to convert this into 30 millimeters. Now they're in the same unit, I don't need to put the units in, but I'm going to times both sides by 10 so I don't have a decimal. As long as you do the same to both sides, they could be equivalent. So timesing 30 by 10 you get 300, timesing 0.1 by 10 you get 1. But I actually want the first number to be 1, so I'm going to actually divide by 300 into both sides. Now you can write that in decimal form, but it's a really long decimal and it goes on and on. So I just found it easier to keep it in the fractional form. But the scale factor is that 1/300th of the drawing.